switch our x and our y. Let's do it to me again. It wasn't doing it all, period. Now it's doing it again. And then our second step was to solve for y. So solve for y. Those are the big packet of pink notes. The big packet of pink notes, sorry. If you weren't here, I'll get you a big packet of pink notes. Anyone else not here that didn't get the big pink packet here? I try to keep them all together for you. So it looks like this. Got it? You can see it. Okay. So what is the inverse operation of x squared? Which means, like, what would I have to do to get rid of that x squared, just to get x alone? What is the opposite of squaring something? Does anyone know? I'm not sure if you ever went over this. Square root, okay? So the inverse operation is the square root. So I'm just going to put that there for you guys to know. Now, what's the inverse operation of cubing something? Kind of a cube root. Very good. So you said square root, which I totally understand. A lot of people say that. But I want you guys to start getting used to, like, the language of math, because when I teach, I feel like some people just get lost because they don't understand what I'm saying. When I say cube root, that means like it's a little square root with the 3's inside. Again, we'll go more over that when we get into radicals tomorrow. But a cube root. So if I were to take the cube root of x cubed, it would go away and I would just get x. That's what the purpose of an inverse is just to get that original where we started from. Okay, so it says sketch the graph of the original function and the inverse algebraically, and then identify the requested information. So first we're going to sketch the original function. So I know a lot of you would like to just plug this in your calculator. You can. So if you have a graphing calculator, you can put an x squared minus 2 in your graphing calculator and you can just graph it. Okay, or you can just know that it's a quadratic, and is it going to be moving up or down 2? Down 2. So if I originally start here, that means I'm going to go down 2. That's now our vertex point. Because originally we were at 0, 0 for a quadratic. But now we're going to go down 2. And again, it just says sketch. So I'm not looking for anything crazy. So I'm just going to sketch it. Okay, it did not have to be exact at all. Because I went down. And we're going to get into transformations more tomorrow, but at least you know that we went down 2. Again, you could have put that in your graphing calculator, 100%, and you could have gotten the same thing. Be careful not to draw a V because a V is absolute value, so just make sure it kind of has a little curvage.
Oh.
Kind of like.
I didn't even notice that. That's a thing.
I just wanted to make sure that you saw that, yeah. Because if you guys draw a V, be careful. Don't draw that. That actually means your absolute value. So be careful when you're drawing things out.
Oh, I didn't know it.
Yeah. Yeah, it did. Well, now you know something. All right. So then it says to find the inverse algebraically. Well, that's what we wrote up here. We have to switch the x and y first. This is what we learned the first day. It was kind of hard for some of you. So if you weren't here, maybe it's a little bit of a recap of how to do this. So the very first step is to switch that x and y. So the y becomes the x, and the x becomes the y. Squared minus 2. So all I did was I switched the x and y. That's all I did. No math being done. Because we know that inverse functions, all the domains and all the ranges switch, or the x and the y switch. We kind of saw that in that table. Now we have to solve for y. So with my highlighter, I'm just going to highlight y, so you know that this piece needs to be alone. That means I must do something with this 2 and this little 2. What would I do first to get it over to the left side? Yes, I would add 2. Okay, and I'm going to put it off to the side, and here's why. And I saw this a lot on your test. People added x plus 2, and you gave me 3x. It's not. They're not the same. So it's x plus 2 equals y squared. If you have questions on just that part, remember, I'm going to highlight just y so you know that our goal is to get everything away. And if I were to cover up y, you can see that squared is still left. What did we just talk about in the beginning that said, what's the inverse of squaring something? That's cute. That's if I was cubing. You're right. So, yes, square root. Very good. So I'm going to take the square root of both sides. And watch what happens. It's kind of cool. So when you take the square root of a square, it cancels. And you're just left with y. And we're done because this is now our function. Now, again, one of the biggest things is people like, oh, y is equal to 5. I'm not looking for a number. I'm looking for a function. I want something to look like a function. Okay, it's technically not in function notation, but I'm not really concerned about that. If you can get to here, I'm happy. If you want to be proper about it because you're proper mathematicians, you can actually just rewrite it, because remember that this little guy right here means it's the inverse of our original, and we're just going to rewrite it, x plus 2. So if you want to be mathematicians and be very proper with it, please do so. That little -1 means the inverse. Now, I'm going to ask you something like just random. Can anyone tell me what I can't have underneath a radical? Is there something that I can't take the radical of, like the square root of blank, a number? What would give me an error?
Negative?
Not 0, but yes, a negative. So if you right now go into your calculator, I get why you said 0, but the square root of 0 is 0. If you put in your calculator the square root of -1, it's not going to work. Your calculator is going to say error. There's a reason for that. Okay? So that means that our domain is now kind of restricted. It's kind of cut off somewhere. So I'm going to kind of help you out here with this one. I actually want you to go in your graphing calculator. If you don't have one, I would go grab one for the rest of the year, because we're going to have a lot of graphs going on. But in your graphing calculator, I want you to go ahead and I want you to plug that in. And I'll show you how to if it loads for me here. Just so that you get used to your graphing calculator. Remember, you can use a graphing calculator on the SAT for the part of the test. In this situation, instead of thinking about what it looks like in your head, you might want to just plug it into your calculator here. Just give me a second. Should be loading. All right, here we go. Go to y equals and clear it out. Hold on. Y equals, y, clear. Okay, you want to press this square root symbol. So that is right here on your graphing calculator. So I'm going to press second, which is the blue button, at least for mine. And I'm going to press that little square root, and it's in red right now. And then we're going to go ahead and put in that x plus 2. So x plus 2. And if you are lost on how to put this in, please let me know, and I will come help you right now. And this is exactly what I was talking about earlier, and how like half of you don't do. People that are not plugging in their calculator right now are the people that did not do well in the test. And there's a reason for it. And that's what kills me inside. Okay, so I'm going to go ahead and press graph. And look at that. We have our graph. What's this point right here? It's kind of an important point. -2. Yeah, -2. So let's go ahead and plot that. I'll come and see. I'm going to go ahead and plot that 1, 2 right here. And again, there's a reason why that's important. Invalid dimensions. Because that means no. Now, why would that make sense mathematically based off of what we learned last week? Yes?
It's a discontinuity?
Yeah, there will be a discontinuity in a way. Here's why. When I put in -2 here, I get 0, right? Because -2 plus 2 is 0. Can I put -3 in? No, because that will produce a negative number. It won't work. Did it work over there? No?
Yeah, I don't know what was on the graph. What was it like this?
Yeah. Okay, so also what we learned too, what was this point again? -2. Yeah, 0, -2, right? What do we know about inverse functions? They swap, and look, there it is. Okay, so you just proved it. And again, I just want to sketch, so I'm just going to sketch this out and just draw it like this. That is what a square root function looks like. You've never seen it? Well, now you have. So if you were able to look on the SAT or whatever you're looking at, this, if you ever just saw this blue piece right here, you would hopefully know or at least recognize it's going to be a square root or some kind of root function. It's like basically half of the parabola, if you notice. It's like half of your parabola. All right, so now let's go ahead and talk about the domain and range. What is the domain? Let's start with our regular one here in purple. What is this domain? Left to right.
Negative 2 infinity.
Yeah, so negative infinity to positive infinity. Right? Because remember, I drew these out to help you. I put negative infinity here, infinity, negative infinity. My pen's starting to make some weird things. Okay, that helps me with my domain and range sometimes. Now, what is the range of my purple graph? So where do I start?
And 0, -2.
Careful. Well, yeah, at -2. We want to look at the y value.
Oh, okay.
So we want to do -2 to infinity. And we're going to include it, and that's why we have the bracket. Hopefully that's kind of a refreshing memory, because we did that in chapter 4, which I know was the beginning of last semester, so I understand why you might be a little hesitant. But if I go bottom up, I start at -2 and I go on forever up. Now let's look at just this. I'm going to highlight it in blue so we can really see it. Just this piece. And I'm actually going to highlight this so that you know that that's the one we're talking about. Domain. Where do I start?
-2.
Good. And I go on to infinity. Very good. Now, the range.
Negative infinity and infinity.
You got to be careful. So look, the range, bottom to top. There's no function here in blue. I didn't highlight anything. But where does it start?
-2 or 0.
0. Okay, remember your range is your y value. So 0 to infinity. Again, I'm sorry, my pen is starting to like make some weird little things there. Now, it kind of makes sense because I told you guys that the inverses, the domain and range, are interchanged. The reason why they're not exactly switched for that is because parabolas technically have all real numbers as their domain. When we're talking about inverses, we'd have to restrict it, but we're not going to go that far into detail. So don't worry about that. All right, we're just going to go to 6C, and then I'm going to let you guys glue the stuff in your interactive notebook and then work on your homework. Okay, so we're only doing, that's it, that's all we're doing today, is just one more problem.
I started on 6 weeks.
What'd you say?
I started on 6.
That's okay. So, now let's take a look at this one. It's a little different. We're starting with a radical, and then we're going to be going to the original. So, the very first step in this problem, when we take the inverses here, is we switch the x and the y. So I'm going to switch this to an x, and I'm going to switch this to a y, and everything else is going to remain the same in black here. So when you're solving for the inverse function, or to put in your graphing calculator, or to plot the points, whatever you're doing, you're just switching the x and you're switching the y first. The goal is to get y alone. I have to ask myself, what would I do first? Remember that this is kind of a group. They're together. I have to get rid of this little housey thing before I do anything. How do I get rid of this little house? What's the inverse of square rooting something? Kind of go back to,
Cube root. Or no.
what was the inverse of square rooting something? What's x2, which is called squaring. So that's why I'm trying to get you guys to understand the language, because when I teach it to you and when you get taught in the future, then you know what I'm talking about. So if I say square root something, that looks like this. If I say squaring something or cubing something, it's to a power of some sort. So they're inverses of each other. So squaring is the opposite of square rooting. So in order to get rid of this, I must now square both sides. And the reason why I put that in parentheses is so that you can see it's a big group. But now look what happens. When you do that, this is going to cancel. And you're just left with that 2y plus 2 inside equals x squared. Again, the goal is not to get an answer, it's to get a function. And we're about to do that. Now again, I want to get y alone, so I'm going to cover it up. Sometimes covering it up helps. What I have to do to both sides to get y by itself? Yeah, I would minus 2 to both sides. And again, you can't subtract negative 2 from an x squared here. So I just have x squared minus 2 equals 2y. And one more step, because again, y is still not alone. What do you have to do to both sides? Yeah, divide. And again, just leave it. Don't try to divide 2 divided by 2. You can't do that. You can only do that if all three pieces had the same thing that can come out. If there's a 2 in front of the x squared, you could. So my final answer is that inverse notation is technically what that is. Again, if you did not have that, you wouldn't really be docked on the test, but it's good to get in the habit of writing things correctly. And I'm just going to rewrite this, x squared minus 2 all over 2. And whenever there's something on top, I personally put parentheses like this because in your graphing calculator, it won't work out if you don't. Okay, so now let's graph some things. Let's first graph the first one. So I'll get out our graphing calculators and try testing it out here. So we go to y equals, I'm going to show you how to put this in. Kind of already did this one. So let's put that in. We have the square root, so second square root of 2x, wait, what is it? 2x plus 2. So 2x plus 2. And getting used to how to put this in your graphing calculator. Okay, you're going to get something that looks something like this. If you didn't, please let me know. Always what I tell people is you need to be looking and you need to be focusing on where it starts. A lot of people on their phones. I start here at 1, negative 1. That's the most important to me. So I'm going to plot that in there, and then it says sketch, so I don't really care about the other points right now. I start at negative 1, I look something like that in red. Again, I don't really care about your accuracy on the other points, I just care about this point. This point is super important to me. Just this one. The rest is just fine. You can sketch it. Now let's do, so this is going to be our original. I'm going to put h of x here so you know that that's what that is. And now I'm going to put in this piece right here. So let's try doing that inverse one together. What? Yeah, the x squared minus 2 all over 2, because that one sometimes can be tricky to put in your calculator, so I want to make sure that you're getting it. So I'm going to clear this out. And I'm going to put parentheses first. I think that's important. So parentheses, x squared, x caret 2, minus 2, all divided by 2. So I'm going to leave it up there for 1 second and make sure that you guys got that. If this is not in parentheses, if you don't have a nice fancy calculator, some people do. Divided by 2, yeah. All divided by 2. Yep, and then you press graph. We can see what it looks like here. And it makes sense. It looks like a parabola. So what is the most important point? Is where it starts, which is the vertex in the situation. What is that? Yeah, and doesn't that make sense? It's the opposite of what we had. Look, this was negative 1, 0. Now we're going to go 0, negative 1. And it's going to look something like this. I don't care how you draw it out as long as you have that one point that's most important to me. They're inverses of each other. A square root and a squared is going to be inverses. So this is f of x. Okay. I'm going to start with the original. Our original is here in red. What is the domain from left to right of this red piece here? So negative infinity to positive infinity in red. The green one, I could see why you would say that, but the red one, where would I start?
Negative 1.
Yeah, negative 1 all the way to positive infinity. Remember, left to right. Now the range, bottom to top. I'm going to draw this out for myself too to help you. Bottom to top. What y value do I start at?
0.
0. Very good. Now, here is where it would be easy to just switch the domain and range, and here's why. I'm not really going to be a stickler on this because it's not that important to me, but technically the inverse function is going to be here because the inverse, the domain and the range switch. That's the cool part about it. Here, negative 1 to infinity. And here's why it has to be that way. You're probably like, well, why did we do that last time? I totally get it. But technically, mathematically, when you're taking the inverse of something, you have to restrict the domain. You have to. So can you tell me what piece of this green parabola matches this inverse? Would it be the right side? Or would it be the left side and why? Very challenging question to ask you. I wonder if you can get it.
What?
Actually, now that I think about it, it's pretty easy if you
Mhm.
just flip your paper.
You can. Yeah, if I were to flip
90
it.
degrees,
Yeah. So which one would it be?
the website.
Let's take a look. So the inverse. Look, it says 0 to infinity, right? Right here. Does the left piece say 0 to infinity, or does the right piece say 0 to infinity?
The right.
The right. Look, I'll show you why. Again, you would not have to really, I'm just trying to get you to explore here. 0 to infinity technically is from this point on. So like, if you have an eraser, erase it, or if not, you can just X out this piece like that. Technically, just these pieces are inverses of each other. This does not count. Again, I'm not going to dock you if something like that was on the test, but I want you to just understand that really this is not the inverse right here. It's just that blue piece. Okay? Does anyone remember, because this is an important question, to see if anyone remembers from, what day was it? I don't even know, Thursday? What is this line that it's technically symmetric about? Remember I had my hand here, and I was like, oh, if I take this arrow and I flip it over, it's symmetric. Not the... Yeah, x equals y. So, something to remember, and I'm going to put a star here. Y equals x is where it's symmetric about. There's going to be a multiple choice question that asks you that. What is the symmetry? What's the relationship between the regular function and its inverse? It's symmetric about that line, y equals x. Okay? All right. So, the remainder of the time will be for you just to glue in your interactive notebook, and then I'll give you your homework once all that's glued in. Okay? So here's the order of your interactive notebook. If you want to just grab your bins for your group, that would be lovely. Okay, I gave you this piece. Obviously, the title, so you can flip right to it, and I'll give you a sticker for it.